All right. Hello everybody, welcome to a Math for Fun video. In this video we're going to go over, I think, 12 exponential questions. So let's jump straight into the first one. Our first question is 2 to the power of x plus 3 is equal to 8 to the power of x minus 4. Now 2 and 8, although they are very similar to each other, we like our bases to be the same when we are working with exponential questions. So is there any base here that we can manipulate to get what we need? Yes, 8 is 2 to the power of 3. So we can rewrite this as 2 to the x plus 3 is equal to 2 to the 3 parentheses x minus 4. Now when we have exponents being multiplied by another exponent, we can in fact multiply those together. So this right here is in fact 2 to the power of 3x minus 3 times 4 is just going to be 12. Now this is 2 being raised to a power, and they're going to be equal to each other. So we can just ignore our 2's here, making this equation now just x plus 3 is equal to 3x minus 12. Cool, now let's just do some simple arithmetic. Minus 3 minus 3 minus 3x minus 3x. This is just going to be negative 2x is equal to negative 15, negative 2, which makes our x equal to just 4.5. Cool. Very simple, easy equation. Didn't take that much room space. But yes, let's just jump straight into our next one. All right, our next question. Q2, find f inverse of x and state the domain and range. All right, so the way my teacher taught me this was we change f of x to just be y, and then we switch our variables, making x equal to 9y minus 2 plus 1. So let's do that. Let's rewrite our equation and then work from there. So this is just going to be x equal to 9 to the power of y minus 2 plus 1. And from here, we can solve. So this is just going to be subtract 1, x minus 1 is equal to 9 to the power of y minus 2. And here, we can introduce a logarithm. Logarithms are what we use to solve exponential equations. We take 9. So here, this looks like the standard form of an exponential equation, which means that we can solve it with a simple logarithm. Now remember, logarithms are how we find solutions to exponential functions. So here's the standard form of a logarithm. Log base b of a is equal to c. It's asking this number to this power is equal to this. So let's make 9 our base. So we're just going to have log base 9 to this power, so we can just set it equal y minus 2 is equal to x minus 1. And there we have it. We've brought our y down to the floor, and we can start just doing normal math with it. So here, just simple one-step equation. We just add 2, and boom, we have found our f inverse of x. F inverse of x is just going to be this right here. Log 9 of x minus 1 plus 2. All right, and now for our domain and range. Now recall, logarithms are the inverse of exponential functions. Exponential functions, they move up like that. Now logarithms, or when we take the inverse of a function, it rotates it, mirrors it. about y equals x. So that makes our function right around here. But this is not just any normal logarithmic function. Recall that logarithms, they all have a vertical asymptote at 0 because we cannot plug in negative numbers here. But we have shifted it over by 1. So while a regular logarithmic function would have a y-intercept, not a y-intercept, an asymptote at 0, we now have it at just 1. Put a dot there. Now there is an asymptote. Yeah, and then from there we can just weep. There we go. So there's our graph. Now the domain and range. So domain is going to be our x values, and we can see it cannot go past 1. So our domain x must be greater than 1. And for our range, well, our range is talking about what y values can our function take. Now this function is going to go down forever, and while very, very slowly, it's also going to go up forever. So we can say our range is just going to be all real numbers. And there you have it, question 2. All right, now our third problem. We're going to find all the intersection points of these two functions. Now, in order to find intersection points of functions, we have to set them equal to each other. And when we do, we can find the x-coordinate of where they collide. And then when we find that x-coordinate, we can plug it into any one of these, and they will get the same answer. That is what it means when we find an intersection point. So, how do we start with this? First, we must set them equal to each other. So this, just g of x, or f of x here, 27 times 4 to the power of 2x is equal to 16 times 3 to the power of x. My 3's are not on point today. I don't like that either. Way prettier. Okay. Now, I like our x's all on the same side, and I'd like our constants just to be with each other. So what I'm going to do, I'm going to divide this side by 3 to the x, and this side by 27. And what does that get me? That gets me 4 to the power of, I'm just going to walk over here because that was not a good idea. That's going to get me 4 to the power of 2x divided by 3 to the power of x is equal to 16 divided by 27. Okay. Now what's our next step here? I think what we can do is maybe we can take something out of this and then we can solve it with a regular logarithm. So recall, when we have a number raised to a power, we can take that power out of it. We can have it be on its own, like that. The same holds true for when it's b squared over a squared. This can just be rewritten as b over a, all to the second power. Now what if it was x? B to the x. Would anything change? No. Nothing would change, I assure you. So what we can do is we can take an x out of this function right here. So this, just draw an arrow, is just going to be 4 squared, which is just going to be 16, divided by 3, all to the power of x. And that is going to be equal to 16 divided by 27. Now we have the materials to set up a regular logarithm. So log base 16 over 3 of this number, our argument, 16 over 27 is equal to x. All right, now you can plug that into your calculator. I have the answer written down right here because I didn't bring my calculator with me. It's just going to be x equals, what was it? Negative 0.3126. Yeah. That is the solution to log base 16 over 3 of 16 over 27. But we want to find the points of intersection. That's just one. This is, I'll set this up right here. That's our x coordinate. What are we going to do to find our y coordinate? Well, we can just plug that number into any one of these functions because this says that at this point they're going to be the same. The same. So plug it in, calculator, whatever you want, and you are going to get 11.349. And that is your solution. Our fourth problem. Here we are. 9 to the power of x is equal to 2 to the power of 2x times 2 over 3. I'm going to go about this the same way we solved our last problem. I'm going to get our x's on the same side. So we're just going to divide this by 2 to the 2x. And then cancel, cancel. And then here we have our new equation. 9 to the x divided by 2 to the 2x is equal to 2 over 3. Now, like we did with our last problem, we can factor an x. Not really factor, because it's not division. We can take an x out of it. We can have this just be the quantity of 9 over 2 squared, which is just 4, all to the power of x. That is equal to 2 over 3. Now, while this might look intimidating, we do not need our calculator to solve this. No, we do not. Technically, we're already done. We can do this just in our heads. Look at this, 9 and 3. What is the relationship there? Well, 9 is the square root of 3, and 4 is the square root of 2. Now these are, it's flip-flopped, so what we have to do is we need this x to be a negative number. So we know x is a negative number because we need this to switch. Now what is an exponent in terms of the square root? What is that? Well, if you don't know, a square root is the same thing as just the half power. And like we did here, if we put an exponent here, it applies to both of our numbers. So we need it to be square rooted. So x is just going to be negative 1 over 2. And there, done. Very nice question. Very simple. Yeah. Very happy that I came up with that.